Okay, Bismillah. Assalamualaikum warahmatullahi wabarakatuh. This is continuation, still in chapter 2. We will continue in section 2.4, which is addition of a system of coplanar forces. Alright, so we'll go straight into it. Bismillah. Rabbi zidni ilma warzuqni fahma, Allahumma aftah lana hikmataka wa shurah lana min khaza'ini rahmatika ya rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Alright, so we have covered the basic of vector, how to express vector, how to write vector, correct notation in terms of writing. We have covered how to get resultant force, resultant vector, and also how to resolve vector right into components. Now, all of those will be used in this point onwards, where we will cover how to add multiple vectors in a coplanar forces. When we say coplanar, meaning everything is in the same plane, right? And when I say that, meaning it's two-dimensional. For example, this is one plane, so everything in the same plane. That is coplanar, right? So how we do this is basically simple, right? If you have multiple vector, right? For example, this vector, this vector, this vector. Alright, so each of these vector can be resolved into components, right? And the easiest component that we have learned, the most straightforward is x and y axis for 2D, right? So, for example, this one will have this x-axis, y-axis component. This one will have x-axis, y-axis component, and this one only have y-axis component, right? And if we can do that, then we can, in the end, add all of the x component and all of the y component, right? For example, for the x component, this and this, just based on the length, you can say, for example, the resultant will be something like that, right? This one is a bit. And for y component, this minus this plus this and minus this one, you might get something like this, right? Based on that, we can get again the resultant of these two, which is this one, right? Oops. Okay, roughly, right? Something like that. So basically, the step will be that like that, right? It's quite straightforward. Basically, for adding multiple vectors, we each for all those vectors, if we can get the x component and y component, we do that, and then we just add all the x component, we just add all the y component with that. Resultant of x, resultant of y, and then we can calculate what is the resultant of the whole thing. Meaning that this resultant here, for example, if we have A, B, and C in terms of vector, so this R here is basically A plus B plus C. Okay, the marker is not better. It's not better. What's a good marker? Alright, this is good. Right, so notice that again, this is from the last recording. If you write something like this, now what this can be understood as magnitude of R equal to magnitude of A plus magnitude of B plus magnitude of C, which is why this will be wrong, this will be correct, right? Because C here, R here is only the addition of A, B, and C if all of this is in terms of vector form. Why? Because let's say C here is, let's take the length to be like, what is this? Let's say 3, right? So minus 3j, right? C equal to minus 3j. As an example, A here let us be like 2i plus 2j, for example, and this one is like minus 3i plus 1j, for example. Is this the same height? For example, right? Now, the magnitude here is 3 also, right? But the magnitude here is you have to find the magnitude at square root of 4 plus square root of 4, something like that. Of square root of 4 plus 4, and square root of 8. etc. Right? So if you add the magnitude, it will not be this magnitude, right? It will be different. But in terms of this one, what you do is basically in terms of our calculation, it will just be R here is you add all the x component, right? So in this case, minus 3i plus 2 become minus 1i, because this is now not x component. For j, 1 plus 2 it becomes 3 minus 3. Wait a second. Okay, this only makes sense if this height is the same, right? Okay, let's change the number. Okay, this 3, this is 2, right? To make it more believable. So 2 plus 3 becomes 5 minus 2 becomes 2 plus 2j, for example. Right, so that is what it would mean when we say vector r equal to vector a plus vector b plus vector c, because the addition process already take into consideration the direction as well, right? For example, this is x component to the left, this is x component to the right, etc. Right? So again, this is a reminder, the way you write is important. Right? Without the arrow, it becomes wrong. With the arrow, it becomes correct. Right? And in terms of the addition, that's what you do. Okay? Hopefully you understand the concept. And normally, we do not need to redraw everything here. We just add all the x component. We just add the y component. Right? And if we need our magnitude is just square root of and then we get a number there, right? This is from Pythagoras, right? So that's how we add vectors. All right. So now, when okay, this is depend on the question, right? Let's take a look at a sample, an example of question, right? Do I have an example here? All right. In the slide, there's an example there where let me put the axis. If we have the x-axis, the y-axis there, and it has three forces basically. Acting on this point, we have where the angle is 3, 4, 5, and then this is F3, 600 Newton, F1 is 300, and then F2 is 450 Newton, this angle of 45 degrees. Now, this is like I said in the class, normally the type of example in this slide is the easiest of the easiest type of question, just for you to be able to relate how to apply the equation, the concept, right? In the exam, it will not be as easy as this normally, but as you can see here, we have also mentioned that you should know how to apply trigonometry by now, right? For example, how to deal with this angle and how to deal with this angle given in this format, right? And if you have not yet watched the video that I put at the very top of the playlist on trigonometry, please do so, because on this type of issues, I have already touched it there. Right now, we'll just apply it. Right. So if you cannot follow how do you apply this and this, make sure to watch that video. All right. So what we do is simply, okay, the question is what? Find the magnitude and angle of resultant force. So find magnitude and angle of resultant force. Okay, the thing that you have to be able to process is, in any given question, especially in the test and also in the final, what is given, what you need to find in the end, and how to get there from what is given into what is need to be calculated, right? Now, what is given is here is clear. There's 1 force, 2 force, 3 force with the angle. And the final is you need to find the magnitude and angle of resultant force. What does this mean? Meaning that, for example, the resultant force is like this, and then you have theta here. So you have to give what is r and theta, for example, right? So that's the end. How to get there? How to get there is, as we mentioned before, if we can get all the x component, all the y component, you add all the x component, you get this x component. You add all the y component, you get this y component. From there, you can calculate this using Pythagoras and this using trigonometry, right? All right. So what to do? So let us first express every force here in terms of Cartesian vector form. Cartesian vector form meaning in terms of I, J, K, right? So F1 here. What is the x component? You should get this in 1 second. What is it? It should be 0 I. Why? Because it doesn't have any x component. It's straight to up there. What is y component? That's the y component plus 300 J Newton. Right. Again, this is a vector, this is a vector, this is a vector. That's why they have arrow. What about F2? So then you have to have the x component and y component there, right? And x component here is to the left, so it must be negative. So negative what? 450 cos 45 I. And then it goes up, so plus 450 sine 45 degrees G. Right? Notice that even though for 45 degrees, sine and cosine it actually give you the same number, right? However, in terms of the step by step, we will see whether this is correct or not based on where the angle is, right? For example, in this case, so cos is here, sine is here, right? So cos is x, sine is what? Even though if you calculate this, the answer will be the same even if you switch, but your calculation method have their own marks, so you will lose there if this is incorrect. What about F3? F3 is, so this is x component, y component, right? So we'll have 600 3/5 I plus 600 4/5 J Newton. Okay. So again, if you think, wait a minute, what is going on? How do you get from here to here? Please go and watch that video for the trigonometry. I believe I have explained it there. I believe so, right? If I haven't, please mention it to me. Alright, so because I recorded that quite a while before, I believe I have covered all of this, meaning how to deal with this triangle. Yeah. So what is FR? The resultant force in terms of. Alright, sorry for the disturbance. So where were we? Okay, now we are calculating the resultant force, right? So how to calculate? Basically, just add all the x component here and all the y component there, and then you get the x component and y component there, right? So in this case, 0 minus this value plus this value. Okay, that must be, because I don't have the calculator with me, so I believe it will be 41.8 I, and then plus 1098 plus 1098 J Newton. Right? This is just simply by using your calculator, you get that one. Right? What does this mean? This means that if you draw it, it will be like 41.8 here, and then like 1098 here, right? If you draw to scale, it will be quite obvious what is the angle should be, right? FR will be here, and theta will be there. Now, so how to get FR is simply just, this is the vector, this is magnitude, right? So square root of 41.8 square plus 1098 square, and what do you get there? 1099 Newton. Right? That's one aspect, that one element or one value that we need to find. Another one is theta. Right? Tangent 1, so 1098 over 41.8, and then you get what's that? 87.8 degrees. Is it still in the frame? Alright. Now, so obviously if you draw to scale, if you make any mistake, it should be easy to notice, right? Because this angle should be close to 9. Okay, again, so my daughter keep calling me. Anyway, now, a precaution. This magnitude is simply a magnitude, but this angle, it can be in the 4 quadrant, right? So if you already draw it here, theta is quite obviously in this quadrant, right? So when you say theta equal to 87.8 degrees, the answer is complete because this is the value and this is where it is. But if you do not draw this diagram, if this drawing is absent, and you simply say theta equal to this one, and you do not indicate where it is, then you are not presenting the full complete answer yet, right? Because it's not clear to me which quadrant it is, right? So some will have something like this, for example, right? Or whatever, to just show, oh, it's in that quadrant, so that the answer is complete. My preference is if you draw something like this, it's easier to follow what's going on and it's clear what the answer is. But any which way, you have to be clear where the angle is for the answer to be complete, and hence the mark to be complete also. Alright. Another example. Should I go to this example? Alright, because it's in the slide, we'll go for the example. So here we have 3 forces. One is somewhere there. F1 is 850 Newton. 4, 5. And then this one, F2 is 625 Newton, 30 degrees here. And then F3 750 45 degrees of lift. Right? So in this question, you are given 3 forces and you need to find magnitude. What is this? How is my writing so bad now? Magnitude of resultant force. Show the resultant in a sketch. So okay, and the question here is have additional show in the sketch. But anyway, so again, you have to be able to understand, okay, what is given, 1, 2, 3 forces with all the angles. What is needed is what is the resultant in terms of magnitude and angle, right? So first thing first, how to express each of these in Cartesian vector form, right? So let's see, F1. We can go from behind, right? Okay. Okay, let's go here. F1. How to express this in Cartesian vector form, right? So you have x component, y component there, right? So x is positive, y is negative. So you have 8, 5, 0, 4/5i minus 8, 5, 0, 3/5j. Right? Again, make sure you know how to use this triangle here. Right? And I do advise do not convert it to angle because you will induce or introduce error when you round off the angle, right? Just use this one, it is more accurate and it's easier anyway, right? What about this one? F2, you get 6 to 5. Okay, x is negative, y is x is negative, y is negative. So here negative 6 to 5 sine sine 30 and negative 6 to 5 cos 30j. Hopefully you can see, even though it go into the picture there, into the diagram. F3. So this one F3, so x is negative, y is positive, so minus 750 sine 45 degrees I plus 750 cos 45 degrees J. Right? So several things. It's not difficult, but several things to avoid making mistakes. One is the positive and negative. Make sure you understand. First, understand why is it negative, positive. Second, sometimes you understand, but you forget to put that negative when you are rushing in the exam. Do not do that. That will be a sad story in the exam, because mistake like that is the worst kind of mistake that you want to do in the exam, because you understand but you just do mistake and you lose a lot of mark. Do not do that. Please check. And third, all these angles you should be able to do, right? You should be able to deal with any type of angle, be it here, or in terms of triangle. See the trigonometry video if you need to. So what will be the FR resultant? Simply for the x component, you just add all of this, you get x component. For y component, you add all of this, you get the y component, right? So I'll just take a look at the answer here. You can verify whether the answer is correct or not by using your calculator. So you'll get minus 162.8 I minus 520.9 G Newton. What does this mean? This means that x component is negative 162.8. The negative is the direction, the value is 162.8. There's no such thing as negative force, right? Meaning force is the magnitude is positive, but the direction is just one way or another. And then this one, the direction is downward, 520.9 Newton. So FR will be here, and theta will be here there. Right. Again, I do suggest that you draw so that when you calculate theta, it is clear where theta is. It's in this quadrant, right? So if you calculate, so for FR magnitude, you simply just square root of this and this, right? That's Pythagoras. Hopefully you have done that. You have covered that one before. You should have. Now, okay, normally I don't put this negative because when you already draw like this, there's no such thing as negative. It's just the magnitude and magnitude. That's Pythagoras. But I just put so that, because normally many students just want to pick up from here, so it will be the same anyway. But so you get 546 Newton. Now, notice that in the slide, the answer will already be in three significant number, three significant figure, right? And for theta here, of course in the slide it's not theta, it's phi, right? Okay, because it's covered. Yeah, it's phi. So make sure what you draw and what you use here is tally at least, right? If you use alpha, etc. So tangent 1 5 to 0.9 162.8, then you get 72.6. Now why is there no negative here? Because actually is from this triangle, so the side of the triangle is it doesn't have a negative value, right? So it's based on the value itself, right? So you get 72.6 degrees. Where this is here, right? It's already clear. So I would suggest make it a habit that you just draw this one. It doesn't take that much time. It's 30 seconds to 1 minute, right? And it avoid confusion. Alright? So hopefully that is understood how to just get the resultant basically you add a vector, right? Add in vector form. When you add, basically what you do is FR if F1 plus F2 plus F3, right? In vector form. In vector form, when you add, you get the resultant basically, right? Okay, so that's the end of 2.4 in the slide, right? I skip all the attention quiz, etc. because you can do that on your own, right? Because for this recording, if we have the class, normally I cover everything, but in this kind of recording, I just skip those things because we need the slide. Otherwise, if I have to rewrite everything, it's not time effective, right? Okay, so that's the end of 2.4. We will go to 2.5 and 2.6. Do we have time? We have another 25 minutes. Alright, so right now we go into Cartesian vector and their addition and subtraction. Right, we have covered Cartesian vector now. Interesting. Okay. Oh yeah, right. Sorry. Okay, before this, what we have been covering is 2D, two-dimensional. So normally when we say Cartesian vector, in real life it's already 3D, right? So that's why you have a 3D vector, right? But the expression is just I, J, K, right? But in this case, there's no G and there's no K because we are still in coplanar, right? In one plane, right? So we go into the 3D calculation. So now, if you go through the slide, okay, I'll erase this first. It covers actually the unit vector, but in this part, okay, we use. Now, the first thing that it introduced in the slide is Cartesian unit vector. Now, when you say unit vector, right? Unit vector. Now, oh, it's too small. Is it too small? But you still can see, right? Okay, unit vector. When you say unit vector, then by default it is a vector, right? But by definition also it is a single unit, right? And it is described as U normally, right? This is a unit vector, right? Now, what makes this important? Okay, before we go how is it important, but let's define what is the characteristic first. The characteristic first is that the magnitude is 1, right? And if you see the slide, the magnitude of unit vector is 1. What does it mean? It means that if you get the magnitude, if the unit vector, you get the magnitude, it will be equal to 1. Right? Meaning that if unit vector have something I plus something j plus something k, when you do the magnitude, what do you do? Square root of this something square plus this something square plus this something square, it will definitely become 1. That's the meaning. Right? If any random vector, it becomes some value there. Right? But when you do this to unit vector, it becomes 1. So that's the characteristic of unit vector. And it doesn't have dimension, it's one direction, original A. So why is it important is because if say you have any vector A like this, right? The magnitude is A, for example. Right? If you have a vector here with a magnitude of 1, right? The magnitude is 1, the magnitude is A. A can be any number. So by definition, this in terms of vector becomes UA. Right? Meaning that it is a unit vector because the magnitude is 1 in the direction of A. Right? Why is this important? Because if you have any unit vector, right? Say I have this unit vector, magnitude of 1, and this is unit vector. So if I have a vector in this direction with a magnitude of 5, right? Then what is the vector? We have covered from the previous recording that multiplication of vector is just you multiply, right? In this case, 5 is this one multiplied by 5, right? So in the end, in terms of vector form, this becomes 5 times u. That will give you the vector, right? You understand that? Okay. So that's why unit vector is always become the first thing that we calculate, right? Because it gives you the vector for any given direction with the magnitude of 1. So when we have magnitude of 10, you just multiply that vector with 10, right? So let's say okay, let's say okay, have we covered that? Okay, basically, okay, we have learned this before, right? In terms of x, y, z axis. If we have, okay, let me ask this question. If you have a vector along x-axis where the magnitude is 1, what is the unit vector? I'll give you 5 seconds. Alright, what is it? Right? You should know this. The unit vector here is I. Right? If you have a vector here with a magnitude of 1, the unit vector is j. Okay. Right? So that is why when you have any vector, for example, I have vector here with a magnitude of 3, that is simply become 3i. Why? Because you just multiply the magnitude with the unit vector. That's why it becomes di, or whatever that is, right? So we have done this without realizing, right? So it's the same that as if you have a vector in terms of ijk. When you have any magnitude there, you just multiply, right? So that's what we do. Okay. So yeah, hopefully you understand that. So that's why we always go to unit vector first, because then it makes it easy when we want to calculate the actual vector with any given magnitude, right? Okay, so hopefully that is understood. Okay, so how to calculate if you reverse the engineering, right? So if you have magnitude of A and in terms of vector of A vector, meaning ax I plus ay j plus EZ K. Is it still in the frame? Right. Right, that's a vector, right? Because X, Y, Z component, and then this is magnitude. So if you need to find what is the unit vector here, UA, how to get it? It's basically just the vector divided by the magnitude. So UA is just A divided by the magnitude of A. The vector A divided by the magnitude of A. So what you get is basically AX I plus AY J plus AZ K over A. Right? Or if you simplify, then you get AX over A I plus AY over A J plus AZ over A K. That would be the unit vector, right, by calculation. Okay. Any question? Cannot ask. Alright, so hopefully that's how you calculate unit vector, right? Now, the next one is Cartesian vector representation if you have a 3D and what to do, right? So imagine that you have, okay, let me check the time. Okay. If you have a 3D presentation like this, which is this is X, Y, and Z, and let's say how to be there, right? Because on top here you'll have also the how to do this, right? Something like that. Where basically this is the vector. Let's say this is A, right? Is it still in the frame or is already out? Still in the frame, right? Okay, if we have that condition, right? Meaning that what makes this resultant is this component AX, AY, and AZ, right? So in Cartesian vector notation, you'll have vector A is AXI plus AYJ plus AZK, right? So X component, Y component, Z component give you that resultant in terms of vector, right? So how to relate the magnitude then? How to relate the magnitude? Now, if we follow the two triangles, right? So if you can imagine, this is one triangle here. This red one is one triangle, where the right angle is here. Right? Can you imagine this triangle here? If you redraw it, it would be something like this. If you see from this angle, where this is A, this one is A, right? And this height here is actually AZ. Right? This height here is the same as this height here. It's AZ. What is this one? This one, let's label this A prime first, because it's in the plane of X and Y, right? So let's say this is A prime. And then let's consider which triangle. I'll consider this one, right? So which color then? Let's consider this blue triangle, where the angle is here, right? That angle. So if you look from top, this is AX, right? This is AY, and this one is A prime, right? If you look this triangle from top, right? So AX, AY, and this A prime here, which is this A prime, right? So I'll just erase this first. Now, based on these two triangles, right? For example, if you go here, right? What is the relationship? Which one do you go for? Okay, let's go here. The relationship here is A prime square equal to AX square plus AY square, right? Or A prime is square root of AX square plus AY square. Okay, let's put the bracket there. Oops, inconsistent there, right? So this is simple Pythagoras, right? This square equal to this square plus this square, or this equal to this square plus this square, square root, like this. What about this one? The same principle apply. So we'll have here A is A prime square plus AZ square, and then you have the square root, right? Is it in the frame? Yes. Now, if you have established this one, and you also know this one, because A prime here is the same as A prime here, right? And if you hit A prime square, this is A prime square, meaning that you can just put this there, right? So that means if you plug in there, we'll have AX square plus AY square plus AZ square, right? So hence you end up with this equation, right? Now what I have shown here is more on mathematical steps to establish this equation. Now in terms of statics, even if you do not understand all of this, you can just memorize this and apply, right? So when you have 3D component like this, where this vector is made up of x, y, z component, so it is simply just like that if you want to have the magnitude. And it's not that difficult to memorize, because it's similar to the Pythagoras for 2D, right? For 2D it's just x squared plus y squared. In this case you have also z squared also, right? But this is how it is derived, right? So it is good to know how everything is derived, so that even if you forget, you can derive yourself. But in terms of application, normally we memorize this already, you just apply this one. Alright. And so that is one way a 3D vector can be represented, where you have the x component, y component, and z component. Now again, I have to remind you, in the just like in 2D problem just now, we have the angle 45, 30, 60, and the triangle, right? 3, 4, 5, 5, 12, 13, whatever. Both can be given to you if you need to solve. So you need to know how to deal with different type of angles. In 3D, then there are several ways the angle can be given. One is just by this. There's no angle given here. You just have the component, and you need to know how to deal with this. So next is if you have alpha, beta, and gamma, right? So hopefully you understand this. So what if this is another way a force can be, or a vector can be represented in a 3D, right? Okay. X, Y, and Z. If you have any given vector there. See. Then it can be also given in terms of angle with x will be x-axis will be alpha, angle with y-axis will be beta, angle with z-axis will be gamma. Now, this by definition must be angle with the positive x-axis, positive y-axis, and positive z-axis, right? Because x-axis, of course, it goes to the back there in the negative x-axis. So alpha, beta, and gamma by definition is to the positive x-axis, y-axis, and z-axis. All right. So with this, you have the cosine rule there, or not cosine rule. Basically, you can just memorize that relationship, right? So cos alpha is ex over a, cos beta is ay over a, cos gamma is ex over a. So it describes az. So if anyone does now, no, you are wrong, sir, it's az, so meaning you are not asleep, you are awake, right? So it defines the relationship between A and also because this is x component, y component, z component, right? And in here you don't have the diagram or the component there, right? But you can determine the component by knowing alpha, beta, and gamma. So it is interrelated, of course, because it is describing the direction, right? And then there's this cos alpha. Okay, this is simply mathematics. Cos square alpha plus cos square beta plus cos square gamma equal 1. Okay, this is purely mathematical relationship, but one of the equation that you should know. You have seen this before, right? But you might have to store it somewhere so that sometimes you need to use it. For example, if only alpha and beta is given, right? For example, in the question does not even give gamma, right? And then you say, okay, alpha given, I can calculate this one. Beta given, I can calculate this one. But gamma is not given. How can I calculate this one? Well, you have this equation here. So if you know 1, 2, this one you can calculate, right? So sometimes the question is sneaky like that. So make sure you can access all of this equation in the back of your head, right? And I'm not sure if you can notice this one. This one, is it familiar? We have erased it just now, but if you still recall, unit vector of E is basically ax over ai plus ay over ej plus az over ek, right? So you notice that it is actually the same thing, right? So if you know alpha, beta, and gamma, you know what is this 3 for the unit vector, right? And obviously it have some interrelation because this unit vector is actually describing the direction. Alpha, beta, and gamma also is describing the direction, right? So of course it is interrelated, right? So if you understand, even if you do not memorize all the things, you can still derive this from understanding this and understanding what is unit vector before, right? Where does this come from? This comes from vector is A divided by A, right? And A is AXI plus AYJ plus AZK, and then divide by vector, you get this one, right? So sometimes it's good to understand, even if you do not memorize everything, you can still derive it yet again. Alright, so we are just about to enter section 2.6, how to add Cartesian vector. However, it is already almost 7 p.m. So it's almost 2.6 now. So how many more to go? 2.9. Alright, so unfortunately I think I have to wrap up the recording right now because I need to rush back. It's already 3 minutes towards 7 p.m. So we will continue 2.6 inshallah in the next recording. Yeah, hopefully we have been able to follow what we have been covering, inshallah. So with that, hopefully everything is clear. That's number one. If anything is not clear, please straight away, before you forget, you can comment what is the issue, and also keep note so that you can ask in the class. And if you have fundamental question like how it's not clear about trigonometry, please review the video on trigonometry that I have posted earlier, inshallah. So with that, I think we'll have to end here. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.